Hello, ladies and gentlemen. This is Mr. Santoro, and this edition of Math 12 Screencast is being brought to you from the math office at Garden City High School. Um, what this screencast is going to look at is the derivative, and we're going to look at the limit definition of a derivative. So we represent the derivative symbolically with f and that little mark there. We call f prime of x. All right. So if you look at the derivative, f prime of x is the limit as h approaches 0 of, and you see this little expression right here, f times x plus h minus f of x over h. So as we move along, you'll see how we are going to take that and use that to derive or to come up with the derivative. So this is on your handout, and your handout just has what you see in front of you now. If you look, the last column has what I just showed you. Okay, let's start. You have f of x equals negative 7x. So I don't know why that popped up again. So you're going to take f and multiply it times x plus h. So if we look at that, we're going to f negative 7 times x plus h. And so I distributed the negative 7. Negative 7x minus 7h. Now the next part of this says you take that, which is this last result on the bottom, and subtract f of x, which in this case is negative 7x. So you take negative 7x minus 7h minus, put that in parentheses, the negative 7x. You have the double negative there. So when you combine the like terms of negative 7x and positive 7x, they cancel each other out, and you're left with just negative 7h. So if you look at this next one says, take the result, f times x plus h minus f of x, divide it by h. So you're going to take the result here, take the result there. I think I got rid of that pop-up message. You take the result here and divide by h. So that's what I did. Negative 7h, divide by h. The h's cancel, and you have negative 7. So now we're going to look at the limit as you approach 0 of this. And we now know this expression is equal to negative 7. So limit as h approaches negative 7 is negative 7. There's no variable to substitute into. So therefore, the derivative of negative 7x is just negative 7. Now, there are a lot of steps here. So if you need to go back and replay this, that's fine. I'm going to do the second example that's on your sheet. So the next one that's on here, we're starting out with the function f of x equals 8x plus 2. Again, where the x is, we're going to put x plus h. And don't forget to drag along the plus 2. So 8 times x plus h plus 2. 8x plus 8h plus 2, I distributed the 8. The next step says take that answer, right, and subtract your original function from it. Now you have to remember you're subtracting, so the original function has to be in parentheses. So I took the result here, 8x plus 8h plus 2 minus 8x plus 2. I distributed that negative. So what happens? The 8x's cancel out, the 2's cancel out, and you're left with just 8h. This one says, take the answer that you got from here, which is 8h, and divide by h. When you do that, your answer is 8. When you look for the limit as you're approaching 0, the limit is still 8 because there is no variable to substitute into. So the derivative of 8x plus 2 is just 8. So if you need to replay this again, do that. In class tomorrow, we have probably 5 or 6 more problems that we're going to do to practice this. Like I said, I know there are a lot of steps, but please try and follow along. Replay it if you need to. This is all algebra and things that you've done. And if you look at the way I have the chart laid out, it just leads you along from step to step to step. So the result you get, the last result in this column, becomes how you start your next column. Last result here is how you start there. Okay. So again, take your time, replay if you need to. And thank you for tuning in to this latest edition of Math 12R Screencast, brought to you from the Math office at Garden City High School.